Hello students, here we are looking at some derivative shortcut practice. As it says here, we've been kind of flying through content, so we need a little bit of time to digest. As usual, Khan Academy stuff should be on your version of this. And let's take a look. Alright, so we've got all kinds of derivatives that we have to take. The goal here is to try to calculate all of these things. There's going to be some involving derivative rules that we know pretty well, some involving some of the newer ones in terms of product quotient and chain rules. Choosing a few of these kind of arbitrarily. 23, I see a product rule here. So if we're finding the derivative when x equals 3, this would be f prime of 3 times g of 3 plus g prime of 3 times f of 3. F prime of 3 is going to be negative 3. G of 3 is 8. G prime of 3 is negative 5. And f of 3 is 1. So we're looking at negative 29 as our answer. We've got a quotient rule. We've got a quotient rule going the opposite way. Let's take a look at 26, and then I want to talk for a minute about that awfulness of 30. So here we've got this function squared. I'm going to rewrite this as 2f of x to the first. Then we got to multiply this by the derivative of that, so that's f prime of x. Plugging in 3. So 2 f of 3 is 1, f prime of 3 is negative 3, and we end up with negative 6 as an answer. I think this says f to the 5th of x, which has a couple different ways that we could interpret that. I'm not sure what the intention of the author was for this. If this was f of x to the 5th, which it could be, this would end up being 5x to the 4th times f prime of x. This could also mean the 5th derivative of f of x, which we don't really have a way to process here. So I don't really know what the intent was. I'm assuming it was this. But either way, don't worry so much about that one. All right, we've got an ugly curve. We need an equation of each vertical tangent, so that's where the derivative is undefined. And horizontal tangent, that's where the derivative is equal to 0. Visually, I can see that we've got some of each of those potentially going on here. Definitely some vertical ones. Horizontal ones, I'm not convinced that ever is going to flatten out. Here's my equation. So first thing we got to do is take a derivative of this. So I'm going to do this up here so I have enough room. X times y, so we got a product rule going on there. 3y squared plus 2x is equal to 8. All right, derivative. Derivative of this is product. So we've got f prime g is going to be 1 times y plus g prime f. Y prime times x minus the derivative of 3y squared is going to be 6y y prime plus 2 is equal to 0. Let's get all of the non-y prime stuff to the other side. So we get y prime x minus 6y y prime is equal to negative 2 minus y. I'm going to factor out a y prime and divide by the other stuff, so negative 2 minus y. And when we do that, we end up getting x minus 6y on the bottom. All right. So we're looking for a couple of different places. The first is when y prime is equal to 0. That's going to happen when negative 2 minus y is equal to 0, so that numerator there. In other words, when y is negative 2. And to me, it looks like this is a horizontal asymptote. So I'm suspicious that this will never happen. We also are looking for when y prime is undefined. In other words, when x minus 6y is equal to 0. Okay, so if x is equal to 6y, I could plug this into my original function, and I end up getting something like this. 6y squared minus 3y squared plus 6y, so 12y is equal to 8. I'm going to bring everything to one side, see if this is factorable. 3y squared plus 12y plus negative 8 is equal to 0. Things that multiply to 24 negative and subtract to get 12. I'm thinking this doesn't work. And in fact, that is not factorable, so you can use whatever method you'd like to get those values. I'm not really concerned. The point that I really care about is understanding that these two things give us vertical and horizontal tangents, and that we can do this type of thing to make that happen. All right, next we're finding a derivative. Ooh, we've got double product rules happening here. So we've got fg, so we've got derivative of f times g, 2xy, and then we've got derivative of g times f, x squared y prime. Change colors. Same thing, we've got the derivative of xy squared is going to be 1y squared plus x times 2y, we need the y prime. Derivative of 2x is just 2. We're trying to find dy dx. I could either solve for that now, but this time we're given a point, so I could plug that in for our x and our y. So this becomes 2 times 1 times 1 plus 1 squared times y prime plus 1 times 1 squared plus 1 times 2 times 1 times y prime is equal to 2. I like plugging things in because then we end up with something that looks like, I don't know why I put an equals there, instead of a plus. All right, then we end up with something that looks like this. So 2 plus y prime plus 1 plus 2y prime is equal to 2. I'm going to move stuff around, and I've got 3y prime is equal to negative 1. Y prime is equal to negative 1/3. Alternatively, we could have factored out a y prime and done our usual stuff. You end up with y prime is equal to, and bear with me for the arithmetic part, 2 minus 1y squared minus 2xy. And then on the bottom, x squared plus x times 2y. And then plug 1 in here, and we should get the same answer. I prefer plugging the numbers in first. I think it makes the algebra easier. If you prefer to do this stuff, that's totally fine. There will be times that that is something we're looking for as well. All right, we're finding the derivative of y plus the square root of xy. All right, well, that's y prime. And then we're going to have 1/2. It's going to be the square root of xy on the bottom because that's the negative 1/2. Times the derivative of the inside. I'm going to write that out symbolically first, just so I don't lose track of that, is equal to 0. So let's take that derivative. I'm going to rewrite this as 2 square roots xy on the bottom. And the derivative of xy is going to be x. I did this backwards, and you guys like doing things the same way, so that's cool. 1 times y plus x y prime is equal to 0. All right, let's move some stuff around. I've only got a pair of y primes in this, so let's see if we can make some sense of what's going on here. I'm going to do some distribution. So we get y prime plus y over 2 times the square root of xy plus xy prime over 2 times the square root of xy. I'm going to set that equal to 0 because I'm keeping that the same. Get my y prime stuff going on. And we end up with 1 plus x over 2 square roots of xy. On the other side, we're going to end up with y over 2 square roots of xy. To finish this up, I could just divide this, and we end up with a really gross fraction, and that's totally fine. I also disobeyed my prime directive that I had a few minutes ago because I didn't pay attention to the idea that we're plugging in a point instead of this. So this is a good lesson for all of us. Because this is a giant mess. And if I had listened to myself way back up here from like 2 slides ago, or 1 slide ago, I could plug my numbers in. And we get y prime plus 1 over 2 times the square root of 4 is 2. 1 times 2 is 2. Plus 2y prime is equal to 0. Cool. Y prime plus a half y prime is equal to 0. Going to move the half over, so we get negative a half. And 1 plus 1/2 is going to be 3/2 y prime. Going to divide that to the other side, and we end up with negative 1 over 3. That's way, way easier than having to go here and then plug that in and then do the same math. So I hope that this ends up feeling like, I think I like talking about giving people math headaches, and then shortcuts are kind of like the Tylenol to that problem. All right, here we've got some new notation, but it's not so scary. This means take the second derivative of this. So we're going to take the derivative. Once we get that, we're going to take the derivative again. So 2x plus 2y, y prime is equal to 0. I'm probably going to get y prime by itself here, just because it's a little bit easier. So we get 2x over 2y. My 2's cancel, and I'm left with negative x over y. So the second derivative, or this stupid notation, d2 dx2, which, by the way, someone decided that it was a good choice to pretend that these actually were fractions and multiply them. So you get d squared dx squared. It's not actually how that works, but we pretend that it is. So here we've got a quotient rule. We're going to deal with this as negative 1y minus y prime times x over y squared. And we don't want this y prime here. The good news is we're given that information. So I'm going to rewrite this as y double prime is equal to negative 1y minus, we said that was negative x over y times x all over y squared. I'm satisfied with you stopping here. You might be able to simplify some stuff if you go a step further, but I'm okay with you just leaving that alone. All right, equation for a tangent line. We've got a point. We need a slope. To find a slope, we need to take a derivative. And we're going to have some stuff with implicit things going on here. So let's take the derivative. We've got x to the 1/2 plus y to the 1/2 minus 1 equals y. All right, so that's going to be 1/2 x to the negative 1/2, which is going to be 1 over 2 square roots x, plus 1 over 2 square roots y, y prime, minus 0 is equal to y prime. Doing the usual, I'm going to bring my y primes on one side. And when we do that, we get y prime minus 1 over 2 root y, y prime. I'm going to plug in my point so I don't make the same mistake I made in the previous problem. And when we do that, 9 comma 4, we get 1 over 2 times 3 is 6. Y prime we don't know. 1 over 2 times 2 is 4. So that's going to be y prime minus a quarter y prime would be 3/4 y prime. And to get that by itself, we're going to multiply both sides by 4/3, and I get 4/18, which is 2/9. Cool, that's my slope. I almost forgot I actually had some stuff to do here. So we've got our y value, 4, plus the slope, 2/9, multiplied by x minus that x value. At this point, we are done. Here we've got a bunch of mixed derivatives. Let's take a look at some of these. So we've got the derivative of e to the stuff. That's going to be e to the sine of 2x squared multiplied by the derivative of the stuff. So the derivative of sine of 2x squared is going to be cosine of 2x squared. And then we got to do the derivative of the stuff inside that function. So times another 4x. Looking at number 2, we've got a product rule, and then we're going to have some chain rules inside of that. So there's my f and g. Derivative first is going to be 3x squared minus 4 to the third power, multiplied by the derivative of the inside, 6x, just 6x, times g, e to the 5x cubed. And then the derivative of that, so it's going to be e to the 5x cubed times 15x squared times f. So that would be 3x squared minus 4 to the fourth power. That's done. We don't want to go any further than that because that's gross. Similarly for number 3, here's my f and g for my product rule. We're dealing with the derivative of the first, 1 over 5x to the fifth, times the derivative of the inside, so that's going to be 25x to the fourth, times cosecant of 5x squared. Then we're going to add to that the derivative of the second. Derivative of cosecant is going to be negative cosecant of 5x squared times cotangent of 5x squared times the derivative of 5x squared, which is 10x, and then times the stuff at the beginning, ln of 5x to the fifth. At this point, I would not touch this and go any further, because if you try, it's just going to get a little bit gross. I guess you could simplify the stuff at the beginning, but who cares? You've done the calculus, you're done. All right, I'm going to put some parentheses to make this a little bit more obvious. We've got the derivative of ln of stuff. That's going to be 1 over that stuff, sine of 4x squared, multiplied by the derivative of that stuff, cosine of 4x squared, and times the derivative of the inside of that, 8x. And a couple more with log base 2. So this is going to be 1 over the stuff, 2x to the fourth, over 4x squared plus 3 to the fourth, with an ln of 2 at the bottom, multiplied by the derivative of the stuff on the inside, so 2x to the fourth, 4x squared plus 3 to the third, times the derivative of the lovely stuff on the inside. That's a quotient rule. So we've got derivative of the top, 8x cubed times 4x squared plus 3 minus 8x times 2x to the fourth over the bottom squared, 4x squared plus 3 squared. Ugh, that's it. Not doing number 6. It's basically the same problem as number 5, but the numbers are slightly smaller.